Well, good morning, good afternoon, everyone, and welcome to today's world's most exciting classroom event. My name is Joe Grabowski, and I'll be your host for today. So we had a little pause in our live events the last couple of weeks because I was in Australia, in Sydney, around New South Wales, and then down in Tasmania, catching up with the DARWIN200 team. We just spent a crazy 2 weeks in Sydney, Australia, and the ship just arrived in Hobart in Tasmania. We've got a new group of Darwin leaders coming on board. After that, it will make its way across the Tasman Sea again, this time to Christchurch in New Zealand, where another group of young Darwin leaders will come on board, and they'll be working on another series of conservation projects. So we're going to try a series of live events from the field, but unfortunately, Starlink didn't come through for us, and they didn't get us connected in time. But no worries, I collected a ton of footage, a ton of stories while I was in Sydney, around New South Wales, and in Tasmania. And over the next couple of weeks, I'm going to release some of those to classrooms as videos that you can check out. And I will make sure that I update in these live events, as well as send the links to the classrooms who have been joining us. So you can check out some of those stories. We're going to get into some Tasmania later tonight, but let me tell you, it was a lot of fun, some great diving, some great exploration, koalas, flying foxes. We met some amazing people. So I can't wait to share some of those stories with your classrooms. Tonight, we're getting right back into the swing of things. We're going to have a guest speaker. I'm going to share some Tasmania action. We have experiments. We've got curiosities of the week. We'll see what else I can squeeze into the hour that we are here together. It should be a lot of fun. But our first speaker is someone who I've known for years, coral biologist Emma Camp. We have met virtually. She's joined in a bunch of live events with me in classrooms. But in Sydney, I was able to meet Emma in person for the first time, which was really, really cool. She was one of our guest speakers. We had a special event at the Sydney Opera House. The ship was able to park alongside at the Man of War steps and then anchor in Farm Cove, which was really, really cool to have the speakers speaking at the Opera House with the big view out the windows and the Oosterschelde sitting in the harbor. It was pretty special. So Emma is, as I said, a coral biologist. She's a National Geographic explorer, and she is looking for super corals. So corals that can survive raising ocean temperatures due to climate change. Because if we can find those adaptations, maybe we can help protect our corals in the future, because over 50% of them have been lost to bleaching events, ocean acidification, all due to things like climate change and our activities around coral. And Emma is working to secure a future for our incredible coral reef habitats, some of the most biodiverse habitats on the planet. So I'm going to grab Emma in here with me right now. Hey, Emma, how are you?
Yeah, good. Hey, Joe, great to see you. Great to be here.
Good, good. Emma, it's so great to see you. I mean, it's only part of you. It was way cooler to see all of you in person. It is pretty cool to have you here virtually with us tonight.
No, I'm really excited to be here. And likewise, it's great to see what the DARWIN200 team has been up to and following them. And it was great to be in Sydney in the Opera House and meet some of the leaders firsthand.
All right. Well, in a second, Emma, I'm going to let you take over. To the classrooms who are tuning in, use the chat sidebar. Don't be shy and send your questions in. But for now, Emma, let's get into your world. Let's learn a little bit more about the corals that you're looking for.
Fantastic. Okay, let's get sharing. And hopefully you can see that all looks well.
Looks good. Perfect.
Fantastic. So as Joe said, I'm a coral scientist. I work here in the University of Technology, Sydney. I have an amazing team, the Future East team. And we're all really passionate about trying to secure a future for coral reefs. As Joe mentioned, they're under threat. So I'm going to talk to you a bit about what our future reefs look like and what our team's trying to do to buy time and give reefs a chance through looking at these super corals. Now, before I go any further, I want to acknowledge the traditional custodians of the land and sea countries where I live and work. So the Gadigal people of the Eora Nation, where the University of Technology is based, but also the KK, Yulanji and Irukandji people, where a lot of my work has been carried out. And just acknowledging them as traditional custodians of language, knowledge and culture, and paying my respects to elders past, present and emerging, and any traditional owners that may be listening in today. So first of all, why care about coral reefs? I think this is so important because it kind of puts in context why I'm so passionate about them and why we need to care about things like supercorals. So globally, at least 14% of the world's coral reefs have declined. But here in Australia, as Joe mentioned, we've been seeing rapid losses of coral reefs, and about 30 to 50% has been lost. Now, that's terrible because over 25% of marine life relies on coral reefs for their survival, but also 1 billion people. So we think of reefs as socio-ecological systems. So many of the poorest communities around the world fundamentally rely on reefs for things like protein, for materials to survive. So that's really crucial. If we think about the Great Barrier Reef here in Australia, it's got a $56 billion asset value, and there's over 100 countries worldwide that have coral reefs. So they're really this critical ecosystem, besides being really beautiful and amazing. Now, unfortunately, coral reefs are declining. So normally they should be these bright yellows and colourful colours. But when stress happens, and particularly warmer oceans, so a lot of the heat that's being generated with fossil fuels gets absorbed by the oceans, and it's really good that the ocean does that, because if not, it'd be a lot hotter on the planet. But it's really bad for the biodiversity and the life in the oceans. And so you can see that the corals turn white. That's why we say the coral's bleached. And that's because the microscopic algae that are kind of, you can think of them like the solar panels of a factory. They take the energy, the light energy, and they create energy for that coral. They leave. They can't survive anymore within the coral. And unfortunately, often the corals end up dying. So the corals can recover for bleaching, but often the stress is too long and too severe, and we see coral lost. And so the prediction for reefs globally is not great. We're predicting that we could lose up to 90% of coral reefs. So how do we do something about that to either slow the decline or ultimately try to reverse that decline? Well, the first thing we absolutely have to do is address climate change. So when I talk about supercorals in a minute, they're not in replacement for addressing climate change. It's the biggest threat to our reefs, and we absolutely have to do that. But even that alone may not be enough. And so that's where we're seeing, what else can we do? Well, marine protected areas. We know that having really good marine protected areas that are enforced, that prevent other stresses like overfishing and destructive fishing practices, are really good to conserve reefs. But again, that may not be enough. We've had marine protected areas in place. We're seeing slowly action on climate change, but we're still seeing a loss of coral reefs. And this is where things like active intervention comes in. So how can science actually try to restore and rebuild the reefs alongside trying to address climate change and conserve the reefs? And so this is really where my exploration and scientific discoveries and interests have come in. I wanted to see, are there corals that are naturally adapted to these stresses that corals are facing under climate change? So specifically hot waters, acidic waters, and low oxygen waters. So this took me during my PhD around a series of different environments with environmental sensors, trying to see what the conditions were. And I found that mangrove corals, so corals living in mangrove lagoons next to coral reefs, naturally live in warm, acidic, and low oxygen waters. So much so that the waters in these mangrove lagoons are more extreme than we're predicting in the year 2100. So this was really one of those like aha moments for me, because these corals shouldn't have been surviving there. They were challenging my understanding as a scientist of what corals could tolerate. So the pictures you can see now are from examples in the Great Barrier Reef, in New Caledonia, and the Seychelles. So around the world, I've gone and I've explored these mangrove systems, and time again, we find corals living there. And so I really want to understand why. Why are these corals surviving when a lot less extreme conditions, corals on the reef are dying? So as I mentioned, they're these natural laboratories. So how do we go about studying them? Well, one thing we do is we put sensors. So that kind of thing that looks a bit like a torpedo in the top left corner, that's an environmental sensor assay. We put that in the water, and it allows us, when we're not there, to measure how extreme these conditions become. And that's really important because things like season, things like tide and time of day can actually affect how extreme the conditions get in these systems. So first thing is to characterize them. And we've done this and we've seen that they really are extreme. And we call them super corals because they've got a superior tolerance to stress compared to normal reefs. Now, the question then is, well, how super are they? How tolerant can they be? And are there any risks with that? So I think anybody that maybe has followed any superheroes, they've typically each got something that's their weakness. So we can think of the kryptonite, for example, with Superman. And so we want to understand actually how super are these corals, but what are the risks for them as well? So the way that we do this is to study the environment. We take some coral fragments and bring them back to our lab to study them there. And we also do something called a transplantation. We take these corals from the mangroves and we put them on the reef, and we take some from the reef and we put them in the mangroves, and we leave them for about a year and we assess them and try to see how they behave and how they change. Now, through doing this, we found some really interesting things. We found that actually these corals from the mangroves can tolerate temperatures several degrees higher when we simulate stress. So that's what we're doing on the right there. You can see we're on the back of the boat. We've got experimental tanks set up and we're basically heating the corals very quickly. And we see that actually the ones from the mangroves can tolerate a lot higher temperature. But what's interesting is when we take the corals out of the mangroves, put them in the reef, so a more stable environment, leave them for a year and then retest their tolerance, they keep their tolerance. So that tells us that it's something innate to the coral. It's something unique about them that they don't lose if they come out of that environment. We found that they have different type of algae. So I said earlier that if we lose the algae, the corals lose their color and they bleach. We found that actually they've got unique algae inside the tissue that adds to their tolerance. So that's part of the reason that they're able to survive. And we've actually found that they're the same species that are found on the reefs, but they have slight differences in their DNA. That means that they express what we would call certain genes and certain traits that are slightly different to the ones found on the reef. And so we're starting to get this big picture of how these mangrove corals are surviving in this environment. So the next part of this then is saying, well, how can we utilize these to maybe build some resilience for the reef? So in 2018, I co-founded Coral Nurture Program. It's a reef restoration program on the Great Barrier Reef, working with traditional owners and the tourism industry. And in this program, we typically use corals that are naturally found on the reef, corals that have survived through previous stress events, which have maybe a bit more superior tolerance. But we're now starting to see how we can integrate these super corals into this practice. Because if we can start to grow up some more of those corals, we can outplant them back onto degraded reefs and hopefully increase coral cover where there's been loss. But importantly, if we can get these super corals to start reproducing, and you can see some examples here of what looks like a witch's hat over some corals. We're actually collecting the larvae that come out of the coral during mass spawning so that we can test them, but also how we can settle them. If we can get these super corals reproducing with some of the natural corals on the reefs, we can start to increase, hopefully, the heat tolerant genes within the population. And this is a process called assisted evolution. It's how can we assist the evolution of the corals in a way that is naturally occurring, but can speed up that process. So it's a long way to go. We have to be very iterative in our approach because we obviously don't want to cause any harm. But because these corals are the same species that we find on the reef, that is really positive because it reduces the risk to any unintended consequences. And we see the super corals as a part of the solution. If you imagine a toolbox of approaches, using these super corals is one tool in that toolbox that can help us hopefully build resilience for the reef into the future. So I'm going to leave it there, and I hope that there are some questions that I can answer, and there's my information, and if I don't get to your question or you think of one afterwards, feel free to reach out to me. Thank you.
All right. Emma, thank you so much for a really cool presentation. We always hear about the negative things that are happening around the world, especially to ecosystems like our coral ecosystem. So it is great to hear that there is reason for hope, to see that there are, people working really hard to try and solve some of these complicated problems. So the work that you and your team are doing is really important. And it sounds like you're making some really good progress.
Yeah, no, thanks, Joe.
So before we move to some Q&A, while you were presenting, I pulled together a little Kahoot quiz behind the scenes because it's always fun to test our classrooms and see how they're doing. So I am going to bring this up here in the background. Those who are tuning in, if you want to start putting some questions in the chat, now's a good time. So they'll be ready after we finish our little Kahoot event here together. And let's see if I can get my screen share going here. So share screen. Pick a game mode. There we go. And I am going to activate it. So the best way to join is to go to kahoot.it. So kahoot.it and for a PIN number. And if you have devices at your seat, well, you can join that way. If you don't have tech to join today, that is absolutely not a problem. You can play in your classroom and see how you do. I know a lot of classrooms as of late haven't been able to join, but that is okay. It is still possible to play the Kahoot in your classroom and see how you do. Okay, so Emma, while we're waiting for a couple more groups to join us, just a quick question here for you to warm you up. And that is, you know what, marine biology is a big field. There's lots of marine life. There's lots of things to explore. What was it about corals that drew you in?
I think it was when I was young, I got to see a reef for the first time. And it was that fascination that you can't see a reef from the surface. You put your head under the water and it's a city, like a full city. There's so much life and color. And for me, that just made me fall in love with just how, you know, amazing it was and how much other life it supports. So that's really what made me fall in love with reefs.
All right, very cool. Okay, so I think we might just have a couple groups with us here today, and that's okay. Let's get this Kahoot going, and then we'll move on to the Q&A portion of today's event. So here we go. All right, first question coming your way. Remember, the quicker you get the right answer in, the more points you're going to get. So here we go, multiple choice. How many people rely on coral reefs for survival? Was it 10,000, 100,000, 50 million, or as high as a billion? All right, good job, crew. That is absolutely correct. About 1 billion people worldwide. And actually, Emma, we had a really cool connection yesterday with Ben from Borreo, a company. We talked about fishing and how, you know, over 1 billion people rely on that as their source of protein. Yeah. And they've collected over 14 million tons of fishing nets. And they've recycled them into skateboards and sunglasses and clothing and all kinds of really cool products.
That's really cool.
All right, that puts the knowing bison into that top spot. Let's go to our next question, a true and false. Coral turns white when it loses its symbiotic algae. So is that true or is that false, that coral turns white after it loses its symbiotic algae? All right, that is absolutely true. And Emma, about roughly how long does the coral have to get some algae back before it is going to die? Because I know it can live for a while afterwards.
Yeah, so some species of corals, it can be just a few days, but some amazingly can actually stay, you know, even up to a few months. And things like sea anemones can also bleach, and we've seen them for like up to 6 months still be bleached but able to survive. So really variable.
Okay, here we go. Next question, true or false? Mangrove corals are surviving in colder waters than reef corals. So is that true or is that false, that mangrove corals are surviving in colder waters than reef corals? Okay, that's absolutely false. In fact, they're surviving in temperatures higher than they've been measured warming. So that's pretty darn cool that there is that variety in corals with that ability, some of them able to survive in those much warmer temperatures. All right, we've got one more question. Knowing bison is still in the lead. What is it called when coral reproduces? Is it called splitting, growing, spawning, or budding? So you have a few seconds to lock in your answer. Is it splitting, growing, spawning, or budding?
Nice.
All right, good stuff. Let's go to our podium. In third place, we've got the Mystery Hawk. In second, the Decisive Dolphin. And holding down that top spot, we've got the Knowing Bison.
Nice.
All right, very cool. Thanks for playing along with us. I'm going to come back from that screen share, turn off that music. If you are the classroom, the Knowing Bison, if you send me a message to classroom@darwin200.com, I'll put that up on the screen. Classroom@darwin200.com. We have a $50 Amazon gift card for your class. So send me a message if you are the classroom, the Knowing Bison, and we will get that sent to your students. Okay, Emma, let's have a little bit of Q&A action. So I've got some questions coming in here via the private chat. I've got some coming in via YouTube. So we have a classroom with us in South Australia, and they are always full of questions here for us. Eddie wants to know how long you've been working with coral.
It would be kind of up to 12, 13 years now.
Okay.
Yeah.
Sid would like to know if coral can glow, so maybe biofluoresce.
Great question. So they can, not all of them, but a lot of them can. They produce pigments. So particularly if you have a blue light at night, you can see some really amazing colors. But in the daytime, if you see kind of fluorescing colors, that's not a good sign, because that's often a warning sign before a bleaching event. So sometimes people are like, look how pretty they are. And I'm like, no, this is a warning sign for me. So if you see those kind of oranges, electric pinks and blues in the daytime, that's a sign that the coral's starting to get stressed.
All right. Okay, a question here from YouTube. How far can a little coral spawn travel?
That's a great question, and it can depend on lots of things: the weather, the type of coral, the currents, but like several kilometers for sure, if not further. So they'll actually go along in the currents, and then they'll eventually start to become competent and settle down. So the currents are really important for corals and for that dispersion during spawning.
Okay. Let's see. Kyla on YouTube is asking, what kind of medicine could come from coral?
So actually, a lot of different pharmaceutical compounds come from something found on coral reefs. It's not always a coral. It might be something like cone shells that are found on reefs. And so things like heart medication, some cancer drugs have actually originated from something found on a coral reef. So for discovery, reefs have got huge potential.
All right. Quinny wants to know, how long can coral live? Is there a lifespan?
So again, some great questions coming through. Thank you. So some corals can grow for hundreds of years. So the massive corals that look like, like a basketball shape, some of those can become 5-10 meters wide. I think that also we recently heard about like the world's biggest coral being discovered, which is really exciting. I don't know yet how old that is, but yeah, they can be hundreds of years old. So really quite a long time.
All right. Arya is asking about the coolest coral that you've seen.
Goodness, I'm going to have to say the ones that are in the mangroves, because, and I know that that's a bit of a cliche, but everything I knew about corals before would tell me that they shouldn't be there. So that branching one, it's called a Acropora millipora. Branching corals, typically people think are actually stress sensitive. So seeing them in these mangrove systems, I think is pretty cool. So that would be my vote. All
right. Spencer's got kind of a cool question. Spencer's wondering how much coral DNA you have or you've collected.
So what's really cool is we actually can take a really small amount of coral tissue to get a lot of DNA. So kind of your fingernail size here, that's what I take to get DNA extractions. So we're not taking too much from the coral. So probably got, over the time I've been collecting, maybe 500 to 1,000 corals that we've taken samples from. But every time taking like a really small amount from the coral.
All right. In your opinion, he wants to know what country has the best coral.
I mean, I feel like I have to say Australia because, it's got the Great Barrier Reef. And yeah, for me, I grew up in England and it was a dream to come and see the iconic Great Barrier Reef because of its sheer size, diversity. I saw someone ask about how many types of coral, and actually in Australia and in the Indo-Pacific, there's well over 600 species of coral, more still being discovered. So yeah, I think I'm going to say Australia for that reason.
All right. Here's a question from YouTube from James. Can coral be found off big cities like Sydney?
They can. It's a really great question. So interestingly, we have subtropical reefs, and so we can find corals around some cooler areas. But also we're actually seeing corals move south. So we're seeing corals, particularly around Sydney, some tropical corals that we hadn't seen as far south as Sydney before, starting to come down with changes in currents and with those cooler waters. And even in places like Florida, they have, a big ports in Miami, which typically we wouldn't think of corals being there, but they're also a type of super coral. We find that some corals can actually survive in these turbid waters and have adapted to live there. So yeah, absolutely, we do find them.
Okay, let's squeeze in one or two before we say goodbye to you for today, Emma.
Great.
Jack wants to know about the size of your team.
So there's 20 people, give or take, at the moment in my team. So we're a pretty big team and working on everything from the genetics of the coral through to how that we can restore reefs at scale. So really diverse team. They're awesome. Great to work with.
All right. And George is wondering, can you remember the first type of coral that you ever saw?
So the first coral I got to see was more of like a massive coral. So it wasn't the branching corals that you saw there. But it was a very yellow color. It was in the Bahamas, and I was about 8 or 9. And that's what led me to fall in love with reefs, because I saw all of the colorful fish, a shark. I saw this marine life around that coral. So I absolutely can remember. And it was one of those moments that's led me to be here now.
All right. Very cool. Well, shout out to our classrooms for sending in all those great questions via the chat and via YouTube. And Emma, such a pleasure to steal you again for another little bit of time and to get to share the work you're doing with some more students.
Amazing. Thanks so much, and all the best with everybody. And thanks for all of the questions.
Awesome. Thanks, Emma. Have a great rest of the day.
See you, you too.
All right. See ya. Okay. Very cool to spend some time with Emma. But we have to keep moving along, and we are going to get into some experiment action. So if you remember, several weeks ago, we had a couple experiments. We had our bioluminescence experiment and we had our sea ice experiment. So we're going to go back in time and we're going to check out the results from our bioluminescence experiment. So bear with me while I get that video queued up here and ready. We'll watch that video together, and then I've got a brand new experiment that you can try with your classroom or at home over the next couple of weeks. So let's take a look at the results from the bioluminescence experiment.
Welcome back. How did you get on with your bioluminescence experiment? You might remember 2 weeks ago, I asked you to think about how you would respond if you saw a bright bioluminescent flash in the deep sea. Imagine you're a predator. How would you feel? Well, for many of the animals that the DARWIN200 team aboard our ship have seen, the use of bioluminescence is a startle response. Animals such as dinoflagellates flash this bright glow, and this startles predators and scares them away. Or the light emitted by the bioluminescence causes the predator to be more visible to other larger predators in the sea. And in those cases, the predators generally abandon their attack and leave the bioluminescent organisms alone. Did you send in your results and guess correctly? Let's find out now who won those £50 Amazon gift voucher prizes.
All right, so there we go. That was a pretty cool experiment, just using a highlighter, which many of you would have had in the classroom or at home. And then you can see the way it glows when it's in the water. In a few weeks from now, we are going to do an experiment with dinoflagellates. Dinoflagellates are little single-celled organisms. They create this incredible kind of greeny blue light when they're startled. And so we have seen that bioluminescence many times on the Oosterschelde at night when we're going through the water. The ship makes a big wave at the front. We call it a bow wave. And that's oftentimes glowing blue. And then behind us, we leave a wake. So in the stern of the ship, it leaves kind of a trail where we've been. And so that can be glowing blue as well. If it's a really wavy night, the tops of the waves will glow blue. And then when I was on the ship sailing from Peru to Ecuador, one of those nights we had that beautiful bioluminescence in the water, and a pod of dolphins were swimming in the bow wave of the ship. It was so dark that you would never know the dolphins were there, except when they were swimming into the wave, they were disturbing the dinoflagellates, and the dolphins' bodies were glowing a blue-green color. It was one of the coolest things I have ever seen in my life. It was super hard to record because the light is so dim. It doesn't really get picked up well by cameras. So I have a tiny little bit of video that maybe I'll share one time with the classrooms that are joining us when we talk about dinoflagellates in a few weeks. So we have a brand new experiment this week. This week's experiment, I'm just going to play it, and then you can see what you're going to get up to, what you'll be challenged to try with your classrooms. So let's get that video loaded up and ready. It should be loading now, and you should see it. Here we go.
Welcome back, everyone. Today's experiment focuses on growing your very own crystals using baking soda. This is a really fun experiment to undertake at home or in your classroom at school. You need some baking soda, about a quarter of a cup or so will do, some hot water from a kettle, 2 jam jars, and a piece of string about 30 centimeters long with 2 paper clips tied to each end. And recommended is some food colouring, which you can use to make different coloured crystals. The first step in this experiment is to fill up a beaker or cup with boiling water. Obviously do so under the supervision and care of a responsible adult, parent or teacher. Try and fill your cup, your beaker, up to about 500-ish millilitres, like I'm doing here. And then you have to add the baking soda. It's very important that you make a saturated solution. That means you put in as much baking soda as possible until no more will dissolve. At that point, the solution is saturated. So do so little by little at a time and give it a good stir. Baking soda often fizzes, so be a little bit careful as you put it in. Just mix it in as you go. And just repeat as many times as you can. Generally, it'll take about approximately a quarter of a cup in 500 millilitres. So just keep mixing it away. So my solution is getting pretty close to saturation. I'm noticing less and less dissolves the more I put in. Let's keep adding it till we get leftover baking soda at the bottom. That shows that no more can be dissolved. There we go. I've put in about 10 spoonfuls of baking soda now, and I think my solution is pretty much saturated. I can see there's a little bit left over on the bottom of the beaker and no more is dissolving. So I think that's about as much baking soda as we can dissolve. The next step is very carefully, you have to pour it into 2 jars or beakers or cups. Remember that the water is hot, so do so again with the help of an adult. Pour in roughly the same quantity in both beakers. So you should end up, yep, that looks pretty even to me. Now comes the fun part. You can choose the colour of the crystals that you're going to make. If you just use the baking soda solution as it is, like this, the crystals will be white. But if you put in food colouring, you can transform the colour of the 2 solutions, which will impact the colour of the crystals that you grow. I'm going to add in some red food colouring and some yellow food colouring to make yellow and red crystals. I think I'll put yellow in here. Let's try a little squirt of that. There we go. I'll just give that a quick mix. And in this one, I'm going to put in some red food colouring. See if we can make some nice red crystals. Give that a little mix too. You're then ready to put your two solutions on an even surface where the water will evaporate away. A windowsill is absolutely perfect for this. So place them there, then add your piece of string with the two paper clips. You can just tie the paper clips to each side. Roughly 30 centimeters or so would be good. Then you have to position the two solutions so the paper clip weighs down the string. You need the paper clip at the bottom of both jars or beakers, but the string roughly horizontal or dipped a little bit in the middle. You then have to leave the two solutions alone for about a week. Come back every day and see what happens. With luck, you should see crystals starting to grow along the string. Replicate this experiment at home or at your classroom at school and send in photos to showcase how your crystals are growing. Email your photos to classroom@darwin200.com for a chance to win one of 3 £50 Amazon gift voucher prizes. Good luck in growing your crystals, and join me in 2 weeks' time to find out the results of my experiment. See you then.
All right, so there you go. We try to pick experiments that are relatively easy, experiments that you can find most of the supplies, maybe in your home, your classroom, a quick trip to the grocery store or something like that. So let's see if we get over the next couple of weeks some pictures of some crystals growing in classrooms or homes. Pick whatever color makes you excited, and we look forward to seeing what you do with your students or with your parents. So before we do our curiosities, I want to take you on a little adventure. So the last 5 days that I was in Australia before I came back to Canada, I went to Tasmania, which is one of my favorite places to visit. Tasmania is such a wild and rugged island full of wildlife and wilderness. And I rented a car and I spent about 5 days driving a big loop around the island. I had my cameras with me, a tent and other cool things. And I basically tried to see as much as I could in as short a period of time as possible. So I want to take you on a little bit of that adventure in Tasmania. I'm going to share some pictures with you. I'm going to share some videos. If you have any questions along the way, feel free to use the chat and send in some of those questions. Let me share my screen and we will get those pictures sharing. And I will take you into that adventure. So here's a little Google map of Tasmania. I'm going to move it on the other side of my screen so I can see what's happening. There we go. Make that a little bigger. Perfect. So I landed in Hobart, and that's where I got my car. The first day I drove down here to the Tasman Peninsula. From there, I went up to this little island. I had to take a ferry to Maria Island, which is an incredible wildlife refuge. No cars allowed there. People can only come there to hike and to camp. Then I drove all the way up through here, stopping at a place called the Tasman Arboretum, and then spending the night in Lungana. From Lungana, I went all the way to this part, this big green chunk of the island called the Tarkine. It's a beautiful rainforest area. It is very underdeveloped, so there isn't a lot of buildings or roads. Most of the roads are dirt and gravel roads, and it's really kind of beautiful wilderness. So that's why I wanted to spend some time there. And on the last day, I went through Cradle Mountain and I flew back to Sydney from Launceston. So that gives you an idea of the route that I traveled over the time that I was in Tasmania. Let's get into some of the wildlife. So the Tasman Peninsula, that little piece of land, is the last piece of land that humpback whales see before they make their migration to Antarctica. And then they spend the winter season feeding in Antarctica. Now, the Tasman Peninsula is a pretty rugged place. Its cliffs are jagged and covered in trees, and it's windswept and cold. And we got pretty lucky because the humpback whales have usually kind of left by now. But because there was some upwelling of food, there was food available, the whales were sticking around a little bit longer. So we went out on a little Zodiac, a little rubber inflatable, and we were surrounded by these humpback whales. So you can see this whale here showing us its tail as it prepares to dive. You can see here, this is a mother and its baby, and they're both kind of showing off their tails in this picture. What's really cool about the tails of whales is photos like these can be used to identify them. So just like our fingerprints, the tails of whales are unique. They have little notches in them, little bumps. On the other side, they have spots in different patterns. So scientists like to collect these pictures of their tails because they can be used to identify the whales over the course of many years. As we go down a little bit, you can see that sometimes they like to wave their big pectoral fins and stick them out of the water. This is the baby, this one of many babies that we saw, and you can see that they love to play. So splashing their fins, banging their tails against the water. Sometimes the big parents will stick their heads out of the water and look around a little bit. When you're really close to them, you can hear and almost feel their breath when they let out that spout that we see, that misty spout that lets us see the whales coming from a long way away. And then this gives you an idea of the ruggedness of the landscape. You can see these rugged cliffs. This is the last portion of land before the whales make their way to the Southern Ocean around Antarctica to spend the winter feeding. And I have a little video clip here that I want to share of the whale, of the baby whale playing around a little bit. So let me see if I can grab the right video. And I want you guys to see this little video of the baby whale playing around a little bit. There we go. So you can see it is very trusting. It has come very close to the Zodiac. It's spinning around. It's slapping its fins on the water. You can see it just took a big breath there. It's slapping its tail on the water. It was really, really relaxed and kind of showing off a little bit for us, which was kind of cool. And then in a second, you'll see it's joined by another couple of whales. So one of them is probably a male and the other is probably its mother. But you can see there's the baby playing around, slapping the water. And probably in about a couple seconds from now, you'll see the other two whales kind of swim through. They're much bigger than the baby. There we go. There's a bigger one. Two of them popping up. 1, 2. And then the baby's still there playing around as well. So it was really cool to be able to just kind of sit in amongst the whales and see how trusting they were, because we weren't approaching them. We weren't threatening them. We were just kind of sitting there and they felt comfortable enough to come close to the boat, which was pretty special. All right, let's get that presentation going again. There we go. What else did we get up to? Well, so this is a little picture of the whale tail as it goes under. You can see all those notches out of it, and the pattern. So you can see how a picture of this, a scientist could identify which whale it was. And then here is an albatross flying by. Albatross are amazing birds. They're some of the biggest birds in the world. Some of them can stretch their wings out over 3 meters, so over 9 feet, which is pretty crazy. And sometimes they spend over 6 months to a year never being on land. They glide over the water. They catch the food they need in the water. Sometimes they sit on top of the water like this one is here. And then they can also have to take off from the water, which is really hard for the albatross to do. So they kind of run across the water like this one is doing here. They have to kind of run. They look very clumsy, flapping their big wings, running on the water, but eventually they're able to take off again. There was other bird life, like these beautiful black cormorants. They're actually a kind of a rare species of cormorant. And if you look closely, you can see, maybe I can zoom in a little, they've got these beautiful green eyes. They're very striking, the eyes that these cormorants have. And so we saw some of them hanging out on the rocks. Some fur seals. You can see they don't always get along. These three here are having a little bit of a disagreement on the rocks. And then you can see they have these big, there we go. These big, beautiful whiskers, which they can use to help sense underwater and to help find some food. So they've got those big, beautiful whiskers. And this is just some more of the birds that we saw. These are some sooty oyster catchers, some shorebirds. So it was a great time in the Tasman Peninsula. You can see here we saw some other birds on the shoreline hunting for some food in the waves. This is a white-faced heron. And before I move on from this little experience on the Tasman Peninsula, there was another something special I did on that first night. I waited till it got dark. I went down to the beach and stood in the dark. It was raining. It was really dark. I couldn't see very much, but I waited for about an hour in the dark, and I was waiting for the little penguins to come home. So Australia is home to the smallest species of penguin. Sometimes they're called blue penguins or fairy penguins or little penguins, and they hunt during the day and they come back to shore to their nests at night. They wait till night because they're so small. They're worried about predators. So they like to make sure it's good and dark before they come to shore. When you wait for them, you use a red flashlight because the red flashlight doesn't affect their vision. If you used a big, strong flashlight, it would scare them away. They'd go back into the water, and it hurts their eyes. So I want to show you a little video here when some of those penguins came to shore, and I was using a red light to be able to see them. So here we go. Let me play this video. There we go. So you can see this is a little set of stairs that go down to the beach. And you can see a couple of these little penguins up on the steps. And you can see they're not sure what to do. They know that I'm there, but they can't really see me. So they're kind of just standing still, we'll say. And so these little guys, these are amazing hunters. So they're underwater. They're incredibly fast and graceful. They spend the day catching fish, and then they bring some of that food back to the nest, back to their chicks. So you can hear them calling too in the bushes. So there's bushes all along the sand dunes, and they make their nests in those bushes. And this was next to a road. So there's a fence that keeps the penguins from going out onto the road, and then a little gate. So you can open the gate to come down and quietly wait for them. But you have to make sure you keep the gate closed because you don't want the penguins to go out onto the road. And then, of course, there's a danger of them being hit by cars. There's another couple of those little fairy penguins. It's really cool to be able to spot them. It was a little cold and wet and rainy, but it was totally worth it to have a chance to see those little penguins. So if we go back to the presentation, I just really like this picture. This is called a fairy wren. You can see this beautiful blue colors. And this was at the first cabin that I stayed at. It kept landing on the rear, or the mirror, the side mirror of my car, and it saw its reflection. So it was kind of challenging its own reflection as if it was an intruder, which was kind of funny, but it let me get some cool pictures like this of that really cool wren. So the next day I went to Maria Island. Maria Island is kind of like an ark for Tasmanian animals. So not a lot of people can visit there, and the animals are protected and safe there. There's no cars and things like that. Nobody can hunt them. So patamelons, wallabies, kangaroos, wombats, Tasmanian devils, they live on this island, and it's kind of a safe space for them away from the mainland. So I want to show you a couple of pictures of some of my new friends that I made when I visited Maria Island, and I camped there for a night. So this is some patamelons, and this is a mother with its baby. So you can see the mother, it's cleaning its baby. And I took a little video of this because I think this is very relatable for some students when maybe their moms are being a little overprotective and trying to keep them close. So if you watch this little video, you can see the baby is kind of like, okay, I get it. Mom, stop. Okay, I'm clean. Knock it off, Mom. You can see the baby is getting a little bit of a cleaning and maybe kind of wanting to escape from the pouch and not really take part in the cleaning for as long as maybe the mom wants it to. You can see it's kind of squirming around, and it finally gets out of the pouch there at the end. Very, very cool. So what else did I see on Maria Island? Let's go through a few more photos. Wombats. Wombats usually are nocturnal, so you don't usually see them during the day. But on Maria Island, they are so comfortable and well protected that oftentimes you'll see some of them out during the day. And then when it gets closer to night, when the sun starts to set, even more wombats come out. So wombats dig burrows, they sleep underground, they eat grass, like you can see a couple of the wombats doing in these pictures here. And they're pretty darn cute, the wombats. They have pouches. They're marsupials, just like the pademelons and the kangaroos and the wallabies. So their young can go into their pouches for safety. And speaking of their young, here's a little picture of a mother with its little baby there. This is kind of getting towards the end of the day here. It's a little bit cloudy and the sun's starting to set. And of course, I have a little video clip of a mother with its baby. So this is a different mom with its baby. But let's take a look at that little clip now. Let's pick the right one. There we go. So there we go. You can see they're like little lawnmowers. Kind of look like round little bears. And they're just doing what they do best. They are mowing down that grass. And you can see that for the most part, the baby sticks pretty close to its mom. And this is right in the middle of the afternoon. So a little bit unusual to find wombats out during the day, but I think they just feel so safe on Maria Island. There really aren't any predators there. So I think they feel pretty comfortable to be out during the day. Whereas maybe on the mainland, it would be more towards the end of the day, the nighttime, that you'd find them. There is a great population of these Forster's kangaroos. So these kangaroos can get pretty big. Some of the males I saw, if they stood up tall, they'd be taller than me. So they can get pretty big. During the day, they're kind of hiding out in the bushes. They're relaxing out of the hot sun. Then in the evening, they come out into the open spaces and they feed on grass. So just like the lawnmowers, they're grass eaters and they kind of mow the grass. And you can see that they're pretty relaxed. The sun's setting. This one's just having a nice relax, chewing on a little bit of grass. In fact, I have a video of this guy as well. It was kind of fun to watch just how relaxed they are, how much they enjoy, just being out. So this one having a nice stretch, nice scratch, munching some grass. The ocean there in the background, really not a care in the world. Maybe a quick look to see what I'm doing. I'm not that interesting, so back to scratching. So really fun to be able to just kind of sit quietly with the animals and capture these little moments with them, these special little moments. Very cool. So if we go on a little bit further, here's some wallabies. This is a mother, and that's its young. I think they're called joeys, but this one's quite a bit larger. This one probably wouldn't fit in the pouch anymore, but you can see they're not hopping away, but they're keeping an eye on me because, you know, I'm pretty big. I make a lot of noise. So they're kind of wondering what I'm all about. What's the deal? The next day, I drove north and went to the Tasman Arboretum because I wanted to see this. I wanted to see a platypus. I think platypus are some of the coolest animals in the world. They're really hard to find. They usually only come out again at night, maybe in the early morning or the late evening. But at this place in the Tasman Arboretum, on a cloudy day, you can get lucky and see them during the day sometimes. So they have webbed feet like a duck. They've got that bill full of sensors that lets them find the food they like to eat underwater. They close their eyes when they're underwater, and they just use those sensors that they have. So that's a nice picture of one, and I was able to take, it's hard to get a video because they don't stay on the surface very long, but I have a tiny little clip. There we go. Of one here sitting on the surface. Oh, it doesn't want to play my video. That's okay. Maybe I'll try and play it at the end. But platypus are unique. They're called monotremes. They're mammals, and there's two monotremes. There is the platypus, and the second one is the echidna. So if I play this little video that I have here of an echidna, you will see the other kind of monotreme. So what makes them so unique? They're a primitive mammal. They lay eggs. all mammals all over the world have live young. They give birth to live young, but the monotremes, the platypus and the echidna, they lay eggs. That's pretty unique. That's kind of a leftover connection to the reptiles who were ancestors of the mammals. So it's really, really cool to be able to see the only two monotremes in the world, the echidna and the platypus, the only mammals that lay eggs. Pretty wild. All right, I think I might have one or two more pictures here. And of course, we can work in a question or two before we go to our curiosities. So let's bring those photos back and let's finish our little tour of Tasmania. The last place I visited was the Tarkine in the northwest of the country. It is remote. It is hard to get to. There aren't many roads. There are gravel, dirt roads, mining roads, logging roads. And to get to the place I stayed, I had to take this little barge. There's this big river. It had rained for days and days beforehand. So the only way to get from one side to the other was on this little barge that was going back and forth. So it was kind of cool to drive over. You can see the river here is surrounded by rainforest. It's always kind of misty like this, especially in the morning and the evening when some of that water is evaporating. Here's another picture of the river here. So just beautiful wilderness. Not a lot of people, which I always think is great when you're exploring somewhere. And here's some of that beautiful rainforest to share with you as well. All right, I'm going to take one more shot and see if I can get this little platypus video to play. I'm going to try and share it in a different way and see if I can get that to share with you. So just give me 1 second. I'm going to open it in a new window and I'm going to try and share that new window directly with us. So let's see if it works this time. So stop my share. I'm going to go to a window. I think it'll work this time. There we go. So here's our little platypus sitting on the surface. Only have a few seconds with it before it dives back down to look for some food on the bottom of this little pond. And there it goes. So cool. Okay, back from the screen share. I'll take a few questions and then we'll finish up with our curiosity. So I see a few questions here in the chat. Charlie wants to know what my favorite animal to see was. I would have to definitely say the echidna and the platypus. They are so cool. They're rare. They're unique amongst all of the mammals. You can only find them in Australia. They lay eggs. So cool. And they feed their young with milk like mammals do. They have fur, but they are a primitive mammal. So it's kind of awesome to be able to look back at that that mammal that still lays eggs. Those were definitely my favorite by far. So I have a question here about how many eggs they lay. And that's a really good question. I think it's 1 to 2. I wouldn't be surprised if it's only 1. So I want to check on that before I tell you 100% if I'm right or wrong. Let's see. So echidnas. Yep, I'm right. So they only lay a single egg. So similar to mammals, right? Well, no, that's not true. Some mammals like dogs and such can have multiple puppies in their litter, but the echidna only has a single egg each year. So just 1 egg for the echidnas. How long are the platypus? I would say that one was maybe about 1 foot. So if you have a ruler in your classroom, it might have been a little bit bigger than your ruler. They're not really, really big. The kangaroos are much bigger. The kangaroos, probably if I was laying on the ground, the big males would be at least 5 or 6 feet long. So yeah, the kangaroos, especially the males, can get really, really big. And they were it was interesting because they all kind of have different personalities. Some of them would let me get really close so I could take some pictures and some nice video. Others wanted nothing to do with me. And if I would get within 50 feet, they'd hop away. Whereas others, I could get and almost touch them. So it really depended on the kangaroo's personality, how close I could get to the kangaroos. Kangaroos. So how long do they live? So in the wild, they don't live quite as long as, let's say, they were in a zoo. If they lived in a zoo, they could live up to 25 years because they're safe from predators. It's easy to find food and things like that. In the wild, they live more like 10 to 15 years, depending on whether it's a gray kangaroo or a red kangaroo. It's always tougher living in the wild. Lots more risks. Whereas when you're living in captivity, you can live much longer because you're taken care of and protected. Okay. Well, that was my adventure in Tasmania. If you live in Australia and you haven't been to Tasmania, you should talk to your parents about that maybe being your next summer trip or something like that. Tasmania is such a cool state. It's wild, it's rugged, and everywhere you look there is wildlife. So I kept 2 cameras on the front seat of my car because I was always stopping and jumping out of my car to take pictures of birds in fields and trees and kangaroos and wallabies and echidnas. It was pretty awesome. So let's wrap up with our curiosity of the week. We have to answer our last curiosity that we had together. Here we go. I'm going to play that now.
Welcome back, everyone. Last week, I asked you to try and guess the identity of this beautiful green stone and what connection it has to electrical wire, these coins, and these parts of a water pipe. Well, believe it or not, even though it's a completely different colour and looks nothing like these objects here, this is actually malachite. Malachite is a type of copper ore, and it's possible to extract copper directly from malachite. So this ore and other types of ore are used to make all of these objects here. And if you don't believe me, look inside this pipe and you can see some of this bright greenish blue oxidized copper, which hints back to the colour of the malachite. Did you correctly identify this as malachite?
Okay, so malachite. I've got a specimen here in my office. Let me see if I can grab it. So the one that Stu had in the video had been through a rock tumbler. So it was really smooth. It took several days kind of rolling over and over again before it got that polished look. And this is what it looks like more when it comes out of the ground. So this specimen is from the Congo in Africa. And then I don't know if you still use pennies in Australia. Probably not. We don't use them much in Canada anymore, but pennies were made of copper. There's copper tubes, copper wiring. So copper is still something important that we use in many places around the world. And to wrap up for today, we have to take a look at our next curiosity of the week. Let me bring it up here for you. Remember, experiments, we have 2 weeks. Curiosity, we have 1 week to send in an answer.
This week's curiosity of the week are these 2 objects here. Can you guess what these are? They're quite hard. If you can work out what they are, can you decide which animal this one comes from and which animal this one comes from? Tune in next week to find out.
All right, there we go. That's our curiosity of the week for this week. I will toss the email up one more time before we say goodbye. Classroom@darwin200.com. If you want to give a try at the experiment, growing crystals, you have 2 weeks to give it a go and send us in some pictures. Classroom@darwin200.com. For the curiosity of the week, you have 1 week to have a think about it. What were those 2 objects Stu had? And then what do you think they came from? So a shout out to our classrooms who joined us today. Thank you for your great questions. Thanks for playing Kahoot. Shout out to Emma Camp, who was our amazing guest today, and the awesome choral work that she is doing. And we're going to sign off for today. Next week, we'll try to have the ship will still be in Tasmania. So maybe we'll get to have a connection from the ship next week. We have a new guest speaker joining us, so stay tuned for that. Experiments, curiosities, always lots going on. But for now, we're going to say goodbye for this week. And we look forward to seeing everybody again next week. So thanks for hanging out with us.